Line segments, or what's a line segment, we'll say. What is a line segment? I happen to know that. Line segment, part of a line, right? Okay. It's part of a line. Okay. So it's part of a line. It's part of a line that consists or has what? Does it go on forever? Has 2 points. What about those 2 points? They are where it starts and ends. So I'm going to say a different word for that, maybe say endpoints. It's part of a line, because a line goes on forever in both directions, that has endpoints. What would a picture of that look like? Point, and connection. So it's not necessarily just, or we can say they add a little bit sometimes more to this. It says part of a line that has endpoints, and then they also can kind of say, hey, it's all points in between, and that's everything between. As well. So it's in between. That's why we draw the line between the 2 points. The thing about that 2 points in a line is that it's a representation of what's there. Because a point itself has no size. Okay? But we need to go, when we look at a graph, we need a location. So the point is a location on a graph. So we have 2 of those locations, and then we're saying that it's every other location between those 2 points. What does it mean to say we're congruent? Oh, those 2 things are congruent. Means those things are the same. So the easiest thing to say there is that they're same. So everything's the same. The book says it's geometric qualities, so it has geometric qualities that are the same. That are the same. So geometric qualities that are the same. That means all of the sides, corresponding sides we're going to say, sides that are in the same location are the same, and all of the angles that are in the same location are the same. That would be congruent geometric figures. When we talk about congruent segments, we're talking about the length exactly is the same. So maybe we should talk about these line segments to be congruent, and how can you tell? So if I go back up to my little diagram, my little picture up there, and say AB. Starts at point A, ends at point B, or it could start at B and go to A. What they say is, I can name that line segment like this. You put AB there, and you put a little line over the top. You guys probably have seen that before, right? We also could say, hey, that's just BA, line segment BA, or line segment AB. What you're not going to see is you're not going to see this. Line segment B is 2. What do you think we're trying to get at here? What am I trying to get at when I say line segment equals 2? This is not the right notation. This is not how you should write this. But what do you think I'm trying to tell you guys or give you information of? Hello? Not that there are 2 of them. What I'm trying to do is say that the length is 2, or the measure is 2. So this actually is wrong. You wouldn't say line segment equals 2. What they do, and I'm going to just change it, is take the line off of it. When you take the line off of it and you say, hey, now we have AB equals 2, what we're referring to is the measure of A to B is 2. That's what we're trying to say. Okay? Now, I could also go up here and say that we have another 2 dots. Maybe I'll even change the color. Another 2 dots. Here and here. And I'm going to call that C and D. Connect those. That's bad connection, but they're connected. And then we would also have line segment CD, right? What if I said that also equals 2? So the measure of C to D, or CD, line segment CD, is equal to 2. What can we say about those 2 line segments then? Yeah, they're congruent. And how would we say that? We don't necessarily put an equal sign between them. What is the congruent symbol? Does anybody remember? It's got an equal sign in it, but it also adds one extra thing. You would have to say AB. We would say equals CD. We could do that, but yeah, not the slash, but a squiggly line, right? Has that little squiggly line above the equal sign. That's a congruent symbol. That means that AB is congruent to CD. Notice that I didn't put the line over the top of it. That's the measure of AB is congruent to the measure of CD. That means everything about them is the same. We're going to use that a lot this year. Okay? I'm losing some space on my slide. I may have to erase some of that as we go along. But, what's a ray? What's a ray? We got a line segment. Now we have a ray. Line segment was a line, part of a line that had 2 endpoints. A ray is part of a line with what? 1 endpoint. Yeah, it has 1 endpoint. And we all know what a ray looks like, I hope. Endpoint, moving on in any direction, really. So we have a ray. What's the origin? Oh, I think of the origin, I think of the start or the beginning. Start, beginning. Okay? The origin is the start or the beginning point, part. Now the origin in different graphs can mean different things. If I'm talking about a ray, the origin would be the point where it starts and then the arrow goes. If I'm talking about of a line segment, maybe that might be a little difficult. Maybe we don't talk about the origin. Okay? When we talk about an angle, maybe the origin becomes a different word for those critical points. Collinear. What does it mean, collinear? What's the collinear mean? Linear means, what's the root word of linear? Line. So it's a line. To be co-lines, or co-line, the same line. And so it's points on the same line. I like that. Points on the same line. So we have points on the same line. What's an example of that? An example of that would be a line having 3 points, A, B, and C on it. Points A, B, and C are all collinear. They all are on the same line. And when I say we have an intersection or things intersect, what are we referring to? Things that cross. So the definition the book wants you to use is that when two geometric figures have common points. So I'm going to say common points. Common points, maybe put parentheses instead. Where they meet, where they cross, slash, meet. Points where they have in common, slash, cross, meet, however you want to say that. So it's a plane, and no, it's not the thing that goes brrrr in the sky, right? Flies over your head. That's not the plane. We're talking about mathematical plane. What is a mathematical plane? Now, flat surface. But here we go. I said something about your desk. Your desk is that little thing that you were kind of writing on. The board is bigger. The wall is even bigger than that. That's also a plane. The floor that's under your feet can be considered a plane. But there's limitations to that, to those things to say, hey, that's a plane. Because a plane is a flat surface with no what? Boundaries. It's a flat surface with no boundaries or thickness. Oops. Has no thickness either. Same line. Collinear is same line. Coplanar means same plane. So points, lines. So we'll say points or lines, or even geometric figures in same plane. What does skew lines mean? Skew lines. If something's askew, something's wrong sometimes, right? But skew lines are lines that never meet. They never meet. But why would they never meet? There's more reasons than maybe they're parallel. Because parallel lines never meet, right? But parallel lines have something in common still. Parallel lines are in the same plane. Skew lines will never meet because they are in different planes. And they're in different planes. Lines never meet and in different planes. It's hard to draw that. I don't know if I can try here. If I have this line here, changing colors, don't use that color, this purple, and this line. But the problem is that there's kind of like a height difference between, it's very hard to show it in 2D. But basically what it is the brown line, what I say, is kind of hovering above. So I guess if you take your arms and hold them at different levels, at different angles, like that, yeah, look at him up front. He's got, his arms are crossing, but yet they're not touching, so they're not intersecting. That's skew. Okay. Types of angles. Now again, when I try moving things around to make it fit on the page, they're going to be a little off from if you were to print them out, because things started shifting around on me. But what kind of angle is that? It's a right angle. And it measures 90 degrees. Already has a degrees after it, so I don't have to put the degree symbol. That makes sense. You guys have probably used that several times already in your mathematical career. Good to go to change, or what's this one called? The line is going what across? Straight. So it's a straight angle. It's a straight angle, and all straight angles measure 180 degrees. In the book, there are going to be diagrams that you guys are going to come across. A straight angle is one of them that you can assume. So if we're looking at one of the pictures, the diagrams, or problems, and the angle or the line looks straight, it's straight. Going back to that right angle, I'm going to go back a page. Going back to here, if I see this picture and it does not have that little box in there, you'd be like, oh, it looks like it's 90 degrees, it must be. Can't assume. The only time you can say it's 90 is if you see that little box right there. Okay, going back. That one, the angle there is an acute fuzzy one. And it measures what? Less than 90, but also greater than 0. So we're going to say between, not a lot of space in there, between 0 and 90 degrees. Between 0 and 90 degrees. If you can squeeze that in there, go ahead. If you can't, oh well. There's enough room, I think, in there. The next one is obtuse. Obtuse and obtuse angles measure 390 and 180 degrees. Initial side. So if I draw myself a diagram here, we talk about rays. Remember we talked about an angle, and we said, hey, an angle is made up of two rays, and it can be a rotation. Well, rotating that top ray up in a counterclockwise rotation, that forms an angle. Initial side would be the side start side. It's the starting side. Starting side. Terminal side would be the ending side. Makes sense. So if I go to my diagram there and I want to put picture to words or words to picture, which one's the starting side? Which one's the ending side? Which one's the initial side? Which one's the terminating side? The initial side is the one on the bottom. Usually, this is called the initial side or the starting spot. We kind of start here, horizontal to the ground, we'll say, or to the ground, and we move up. That's usually our initial side. Our terminating side then would be where we're turning to. And you can see the arrow is pointing inside there, is curving up to that terminating side. And tick marks. What is so special about tick marks? How do tick marks help us? What is a tick mark? You guys may have used them before. They designate segments of equal length. So basically, it allows us to say this segment is congruent to that segment. Or if we're told two segments are congruent, you go on and put tick marks. And I'll show you on a diagram what that's going to look like. It also, and angles of equal measure. So not only can we say, hey, these two segments are the same, we can say, hey, this angle, angle A, and angle B are the same. So, where can we see that? Well, if I drew two triangles, I then can go back and say, hey, those two sides are the same. We put them a single tick mark on them. Maybe the side on the, oh, totally missed it. The right-hand side on top, they are the same. So put two dashes or two tick marks to represent they're different than the other side. I can do the same thing for angles. Put a single band or single kind of curved mark in there. Say that those two angles are the same. And I can go back and maybe put a double angle. That was bad. Double angle. Those two angles are the same. We have a diagram there. Everybody do me a favor. On your diagram, somehow it got left off. Put the box in there. When I created it, I somehow forgot that. So, what do the angles 1 and 2 equal? Basically, when I add them up, what does that equal? Annabelle? 90 degrees. And when I add angle 1 and 2 to get 90, we see these angles are... You got some nice shoes on today, guys. Complementary. They're complementary angles. Complementary angles add up to 90 degrees. Looking at that diagram, angles 5 and 6 will add up to what? 180, because they form a line or a straight angle. What are these called? Supplementary. Supplementary angles. And then on the bottom there it says hint, they form a, I already said that. Straight angle. It's 90 minus A. Whatever the angle A is, you subtract it from 90, you'll know what the other one is. That's the complement. Using the same logic, going down to the supplementary angles add up to how much? 180. So the supplement of angle A is what? 180 minus A. Those are what's going to take the words when we write our equation for the complement of angle A. The supplement of angle A. That is 90 minus A and 180 minus A. So now we actually have to write the equation so we could solve it. Okay, so it says the complement of angle A. Okay, so we should know 90 minus A. And then it says is. Whoa, what mathematical symbol is? Equals 20 less than half the supplement. So should I write 20 minus half of something? What's that something? That something's 180 minus A. Is that the equation? I'm going to pause here and kind of talk about this. So 90 minus A is correct, but it has to be half of that supplement of A. So it's half of the supplement. Does everybody understand the half of the supplement? Then I can take 20 because it's 20 less than the supplement. That's the hardest thing about these problems, is trying to figure out the order to write the equation. To be less than something, you need to know what the something is first, and then you take from it. If it said it was 20 more than something, well, then you're adding, and adding doesn't matter, right? Adding is commutative, so you can add things in different orders. But subtraction, you can only subtract things in the correct order, otherwise you get something wrong. From here, it just becomes, hey, evaluating the problem. What do I do with the 1/2? Distribute. So nothing's going to happen with the 90 minus A. That equals 1/2 times 180 is 90 minus 1/2 times a negative A. Negative 1/2 A, or minus 1/2 A. Minus 20 because we didn't touch it. I know it's getting a little smaller. I'm running out of room. I'm not going to do anything with the 90 minus A side. But 90 and the minus 20 can be combined to make 70. 70 minus 1/2 A. Now we can start to move things left and right. What do we want to move? I'm going to try this once. I moved that last row all the way up to the top. So, now I'm going to take the 70 and move it to the left. And I'm going to take the minus A and bring it to the right. Can I do that in one step? Is everybody going to be okay with that? As long as I show work? So minus 70. And then I'm also going to, what? Add A. So the A's will disappear on the left, but the 70s will disappear on the right. Correct? Yep. And what is 90 minus 70? 20 equals, if I have a negative half and I get a 1, I'm a positive 1/2, or just 1/2 A. If I'm 50 cents in the hole and someone gives me $1, I'm 50 cents in the positive now, right? Or $0.50 in the positive. How do I get rid of a half? Multiply by the reciprocal, which would be 2 over 1, or multiply by 2. Or you could divide by half, but when you divide by a fraction, you flip and multiply, which is multiplying by the reciprocal. Multiply by 2, multiply by 2. The 2 and the half will cancel. A is 40. Homework is on page 12, problems 1, 6, and 7.